Professor.
Good morning, Simon. How are you?
All good, how are you?
Doing good. So have you ever wondered why in these jugs right here, that after you let the water drain for a little bit, it starts to slow down a lot?
I have no clue what's going on.
All right, here, let me show you something. Now, taking the top part of the jug off, what do you think that's going to do to the water?
I think it'll make no difference.
No difference? Here, watch this. Came out a lot faster, didn't it?
Yes, it did.
So the reason behind that is because of Bernoulli's principle. And here in a minute, I'll get to explaining that. So here in the meantime, here, enjoy some water.
This is too hard. This is too complicated. I'm dropping out.
All right, so here we got case one. This is when the jug is closed. And so we use Bernoulli's principle to find out that the pressure at 1 is greater than the pressure at 2. So one thing we know is that at the top of the tank, that the velocity is 0. Then we also know that at the exit area, that it's atmospheric pressure. So we also know that pressure 2 is at 0. Z2, which is at the bottom, this reference point right here, is at 0 because we know that Z1, there's an elevation right here. So we can make Z2 equal to 0. And by knowing that, we know that the pressure at 1 is greater than the pressure at 2, and that's going to lead to a slower velocity coming out the bottom. So here, this is case 2. This is when the jug is open. So we also got Bernoulli's principle written over here, and then we know that now the pressure at the top is atmospheric pressure, 0, because it's exposed to the air. So here at Z1, there's going to be an elevation. You're going to have no velocity at the top because the water's just staying in there. We know pressure at 2, open atmospheric pressure, is also 0. Z2, like we established in the one before, is also 0. So now that the pressure at 1 is equal to the pressure at 2, they're both exposed to atmospheric pressure. So we know that the velocity is going to be faster. So next thing we're going to do is we're going to calculate some flow rates to prove that it's faster. All right, so what we got here is the top of the jug is closed. So obviously we're going to prove that it's going to be a slower flow rate coming out. So what we're going to do is we're going to time how long it takes for 2.5 gallons of this jug to go down to 1 gallon with the lid closed. So start our first experiment. All right, so obviously this is going to take way too long to go from 2.5 gallons to 1 gallon. So we're going to go ahead and stop this right now, and that we all just know that it's a flow right now. So we'll stop this and we'll do our experiment 2. All right, and now for the second experiment, what we're going to do is we're going to drain the jug with the top open to atmospheric pressure. So we're basically going to prove that the water coming out is a lot faster. So what we're going to do is we're going to go ahead and start. All right, so we just have approximately drained about 1.5 gallons of water, and we got that it took 1 minute and 41 seconds to drain it. So now the next thing we're going to do is we're going to calculate the flow rates coming out of the jug.
Now we come over here to calculate the flow rate. The flow rate is given by the volume divided by the total time taken. And for the closed part of the experiment, we drained 1.5 gallons of water, but the time it took too long. So we didn't get the approximate time. But since the denominator is way greater than the numerator, this value will come out to be a small number. This small number is the flow rate for the closed part of the experiment. And now we come down to the open part of the experiment. The volume that was drained was 1.5 gallons in a time of 161.66 seconds. And the flow rate came out to be 0.557 gallons per minute. This one turned out to be a large number, which we gave as Q2, we labeled as Q2. Since Q2 is greater than Q1, this proves that the flow rate in the open case is greater than the flow rate in the closed case. Therefore, Q2 is greater than Q1.